Welcome to Answer Everywhere. Today we're taking a look at Metasploit, the well-known framework for attacking people with your computer. I have not used Metasploit, and I am barely really aware of how it's architected or anything like that. I think I've seen it used in various like DEF CON or Black Hat talks. So I'm kind of aware of what it's for, maybe what some of the things are, but we'll take a peek. Greetings from Uruguay. Hello, welcome. How are things there? Reepa Cheepy. I like that name. Okay, so my guess, just based on what I think Metasploit is, we'll do a prediction and then see if the prediction is accurate. But my guess is that it's going to be architected as maybe a folder of exploits, basically shell scripts or Python scripts, some sort of scripting language that is able to run on multiple different systems. I assume that it will run on like Windows and Linux as the host machine. And there will be some system for putting in like parameters, like if you need to execute an exploit on port 1234556, that needs to be entered somewhere. So there might be a UI, it might be a command line UI. But then there will be kind of like a controller that's general enough to be able to plug in stuff like that, execute scripts, and maybe some searching functionality to help you find an exploit that is looking for that is, given that the host network looks like this, or the the target network looks like this, or the target machine looks like this. There might be some stuff in here to help you figure out what you should be doing, but we'll see. So this is saying Ruby. Am I on the wrong thing? Is Metasploit really written in Ruby? Let's double check this. A computer security project that provides information about security vulnerabilities, such as and aids in penetration testing and IDS signature development. I don't know what IDS signature is. Intrusion detection system. Okay. It is owned by Boston, Massachusetts-based security company Rapid7. So it has an owner. I didn't know that. Its best known subproject is the open source Metasploit framework, a tool for developing and executing exploit code against a remote target machine. Other important subprojects include the opcode database, which I'm going to guess is a database of opcodes, maybe organized by the type of machine or system the opcode is an opcode for. Shellcode archive, presumably that's like scripts and stuff, and related research. It includes anti-forensic and evasion tools, some of which are built into the Metasploit framework. Okay, so that's that. It is written in Ruby. Okay, I never have written or read Ruby, so we'll see how it goes. We have gem files, which I believe gems are the unit of packaging or something along those lines for Ruby projects. We have Kubernetes. I don't know if this is attacking Kubernetes or hosting Metasploit stuff on Kubernetes. I guess we'll take a peek at that. Lib, I will guess, is probably where a lot of the action is. Documentation and docs. I don't know how docs are different from documentation. Then we have Docker. Again, I don't know if this is for attacking Docker or hosting on Docker or both. And then we have DB and data. These could be possibly directories that have the exploits in them. And config, maybe config is important. App is probably important. Modules is almost certainly somewhat interesting. Plugins, script with no S and script with an S. Spec, test, and tools. I guess let's just open all the things because all of these seem like they could be, given what Metasploit is, these all seem like things that could be interesting. And when we have a lot to do, sometimes I like to rule out things that are actually that actually don't look interesting on first look. So I guess let's try to do some of that. This is tools. This folder contains standalone scripts that can help developers and users with various tasks, such as MSFT Tidy, I guess Microsoft Tidy, which checks modules to make sure they conform to linting rules. Oh no, this is probably not Microsoft. This is probably Metasploit framework. And MSFT Tidy docs.rb, which does the same for documentation files. So these are like tools for, I guess maybe for like developers, maybe? What is passwords? Password. CPA password decrypt, VX digger. These might be interesting. Let's look at lm2nt crack.rb. We have this module requires Metasploit. Okay. It contains cracks. This script cracks any type of NTLM hash. I don't know what this is. Some kind of hash. In Windows, NT LAN Manager. Okay, so this is for cracking Windows NT LAN Manager hashes. I assume that if we can crack them with off-the-shelf code, then those hashes are mostly out of date. And again, I've never read Ruby before, so I don't really know anything about the syntax, but I'm going to guess it's similar to syntax from other languages I do know. So this is, I guess, just this while seems like maybe it's just checking if this file is a symlink and then kind of using it as a resource, and maybe on end it releases the resource. I don't know. But we're going to, if it is a symlink, we're going to expand the path, I guess, to where it really is. We've got this unshift thing. This is, I guess, just, it seems like it's just manipulating file path names. And we're looking for stuff with lib. And we have, whatever unshift is, but it seems like we're looking for Microsoft, or no. Metasploit lib probably. And this is maybe just looking in your environment for things you might have done to configure Metasploit for the way you like to work, or your local machine or whatever. We have this usage thing, which seems like a help string. So we have some options. Oops. Come on, GitHub. So we can use this tool in 3 ways. Whatever type is chosen. So if only a password is provided, we'll display the hash. If a password and a hash and an hash is provided, it will test the password against the hash. So presumably hash the password and just compare the two. And if a list of passwords is provided and a hash, it will try to brute force the hash. I guess, I don't know, like using the passwords, or, I mean, is it considered brute force to just try each password? I don't know. So we've got this permute PW, fast permutation from hacker, sorry, Stack Overflow. Okay, so we're just going to copy and paste from Stack Overflow. What a great opportunity to put one of my classes of derivation of algorithms, the Dijkstra method. Okay, so what is this question? A snippet of Ruby that would take a string and output all possible permutations of capitalizations. Okay, so they're gonna do things like if you have maybe like the word puppy in the password that you're passing in, they're gonna try things like capital P puppy, or like capitalize the first U. I guess there's only one U. And that's to essentially feed in a list of case list passwords, and then be able to match passwords people know to like capitalize something in their password. So it's just kind of like looking for that. So this is just some permutation code they copied and pasted. Nowadays, I guess you would copy and paste this from ChatGPT. And we've got this thing, which is possibly setting all of these things to be equal to each other. They're all nil, I guess. And we've got some sort of parser. And this looks like maybe command line argument parsing. The username, domain, the type of password to crack, which I guess is one of these things. Is that how I'm supposed to read this? All right. And then this seems like more command line argument parsing, blah, blah, blah. Is the file readable, et cetera, et cetera. So if we have one of these types, so we've asked to crack some sort of password. If we have one of these types like NTLM or LM or half LM, then we look at servcal and clycal and user, et cetera, and check that they're non-nil. And if so, we're going to put some error and say no challenge user or domain must be provided with this type. Okay, so this is just enforce. So some of these flags, these command line flags, have dependencies that are not modeled as, you could imagine modeling them as some sort of tree or DAG. And instead of doing that, which I think nobody really does, they just have these like snippets of code to say that you can't use these two flags together or whatever. All right, and are we finally down to real code down here? We've got some sort of, this appears to be a switch statement. Switching on, I guess, what? I don't know if this is saying switch on type. If the type is maybe half LM, then I guess maybe we switch on mode. And if we were in brute mode, then I guess we check if the hash matches this regex. Does Ruby have like in language support for regex? Then this seems to be some error. It will say it has to be the half LM hash must be exactly 16 bytes of hexadecimal. Otherwise, I guess we do match this regex. Then we're going to open the password list, and for each line do some stuff. We're going to substitute /r/n with /n or vice versa, depending on. I guess we're replacing line breaks with spaces or vice versa, depending on what the syntax of gsub is. Essentially, maybe the file is lists of passwords separated by spaces, and we want to turn it into something separated by lines or whatever, or vice versa. And then if the password is matching this regex, which seems like it's what starts with something between 1 and 7, and that's, I guess, all there is. Or no, it starts with anything and it's like 7 long or whatever. Then we're going to put the password, put string, maybe write the password. We're going to calculate the hash and do some stuff like call lm hash password true. I don't know what true means. And then we're going to unpack h star, whatever that means, 0, and I guess convert it to uppercase so that maybe it's the hash that's uppercase. And if the calculated hash is equal to the hash that we computed, or rather, I guess that was passed in, we're going to say that we found the correct thing. So I think that what this is doing is that it is, for each password, it's computing the hash and comparing it to the hash that we passed in. So we've got some password file, and we want to essentially brute force some hash that we know about. And that's what this is doing. It's just hashing all the passwords. But is it actually using this routine that permutes stuff? I don't think so. I don't think yet. And similarly for the other stuff, I'm going to guess. Okay, so that's just one script. That is that's like a little taste of what we're doing. All right, and so let's go back to the beginning. So here's lib Kubernetes. What is this about? Metasploit in Kubernetes. So the most common workflow is to test a Kubernetes environment with Metasploit is to target the API externally, the Kubernetes API, or through a compromised container. Okay, so this is attacking Kubernetes. I was wondering whether it was hosting or attacking, but that's useful to know. DB So this contains modules metadata base JSON, which contains information about all modules. Hello. I don't know how to pronounce this. Call Carl. Is call Carl almost close? And hello and welcome. Okay, so contains modules metadata base.json, which contains information about all modules within Metasploit, as well as schema.rb, which describes the current state of the database schema maintained by Rails Active Record. I don't know what Rails Active Record is, but this seems to have information about the database. We've got migrations, and the migrations seem to be empty. I don't know what git keep is. Is that like a is that for large files or something? Is it Google Keep integration? Oh, git keep is the opposite of git ignore. Okay. So are we going to keep anything? We're going to keep nothing and like it that way. So schema RB, I'm guessing this is just for some data, like storing your stuff in the database. GitHub does not want to show me this file because it's huge. And this is like the database of all the things. So how big is this? I'm going to grab this and shove it here. That's a lot of lines. I was going to see if I could ask Gemini to summarize what's going on here, but I think even Gemini will hate me if I do that. But what if I just look at the names? What? Oh, I need to do that with the, okay. So now we have only 6,000 lines. Hey. Where did occur go? Oh, it's a capital O occur. Okay. So some of these are not so interesting, like this cleanup stuff, create list, but some of these are. So 2wire, cross request forgery password, reset vulnerability, and so on and so forth. Apple TV remote control, Apple TV video. Can I just omit this stuff? I guess I could use JQ to pull out some name stuff. But we'll not go that far. A bunch of Netgear stuff, Linksys. So these are like routers or network gear. Postgres I saw. Oracle. SAP. OpenSSL. SendMail. What about LiveJournal? Seems like LiveJournal is impervious to attack. Atlassian. Okay, so lots of stuff. You could grab this and throw it into to some LLM and ask it about to summarize something about which, sorts of things have the most vulnerabilities against them or whatever. Lots of PowerShell stuff, Unix command stuff. What about Google? WordPress, Google Maps plugin, some Google Chrome stuff. I don't know how old this is. Some Firefox stuff. Okay, so exploits. That just gives us a sense of what sort of exploits we have, and then schema.rb, I'm going to guess, is just organizing the database. We should see something like a SQL query. Yeah, so we have create tables and probably inserts. Maybe not inserts, just create table stuff. Okay, fine. Then I don't need to look anymore at the DB. What about the data directory? This folder contains various data files used for a variety of purposes, including, but not limited to, banners for the console. I guess like for displaying things like Toast or whatever. Exploit source code for exploits under data/exploits, template code and binaries, word lists, and shellcodes. As a general rule of thumb, this folder will most often be used when you're using compiled binaries or source code from other exploits for cases such as local privilege escalation exploits, and need to provide the exploit code and compiled binaries so that maintainers can verify the binary and compile it themselves. What are you talking about? Okay, I'm not sure what that, like, what else would you do if this is the thing that has the exploits, but maybe it doesn't have all the exploits. So let's look in data exploits. And they're organized by CVE, which is useful. Let's pick one that's old enough that maybe won't get me in so much trouble if it's still lots of vulnerable machines. Okay, so we have this README, which is just some HTML file that says to do. We have some pictures, the logo for maybe that's the Metasploit logo. And then we have some XML for the plugin, and then a lib. Let's look at the lib. We have plugin metasploit.jar. This is a jar file. I guess this is basically what they were saying about binary. So this is I guess like rendered code or compiled code. I don't know if you call a jar compiled, but it's not the source code. It's the stuff that runs on the VM, I guess. All right, so here's lib. What else do we have? Config. I guess we've seen enough to believe that config is probably not so amazing. App. This directory contains active record concerns, models, and validators. What is active record? I thought that was a Windows thing. Active record. Oh, so it's just a pattern. Architectural pattern is found in software that stores in-memory object data in relational databases. Oh, okay. So this is like a like live data. Because the data and database access methods are in the same file, those files end up being bigger. Approach to accessing data. Database table or view is wrapped into a class, thus an object instance is tied to a single row in the table. After creation of an object, a new row is added to the table upon save. So this is kind of like ORM. It's commonly used by object persistence tools and ORM. Okay, so that's what they mean by active record. It's just some in Ruby model of the database. So we've got things like validators, whatever a concern is, I guess like a cross-cutting concern, and we'll ignore it. That doesn't seem to be at the heart of what we're doing. Here's auxiliary. We have things like exploits, NOPs, and payloads. This looks interesting. This is where all the Metasploit modules live. These modules are scripts in Ruby that interface with Metasploit itself to perform some specific task. Okay, so this is maybe the mother load, but we'll get to that in a bit. Here's plugins. I'm grateful for these readmes, by the way. These save me time. They're not long. They just get straight to the point, and that's useful. Okay, so this is where the plugins for Metasploit live, which allow the Metasploit interface, which allow Metasploit to interface with other tools and services. Okay, so these are connecting Metasploit to other tools so that you can maybe do things like script Metasploit or whatever. So I'm going to ignore that because I don't think it's going to be as fun as modules or lib. Here's rails.rb, which will be automatically run when the command rails is run from the root of Metasploit itself, and allows Rails to populate its list of additional commands that are available for users to use. So this is maybe some Rails support, which we can ignore. We no longer support Meterpreter scripts. I've heard of Meterpreter. Is it a similar thing? So that folder should be deprecated. But then we have other scripts like resource and shell. And shell just has one thing that's called migrate. So I guess maybe this isn't such a great folder. And then spec. All RSpec related to unit test files reside under this directory. So this seems to be testing. RSpec, I'm going to guess, is the unit test or a unit test framework for Ruby. And just for completeness, let's verify that. Behavior-driven development for Ruby. Okay, great. And this is more tests. And they have tests for Kubernetes and tests for libs. We have functional tests and hooks and all that stuff. Okay, that's good. I'm not going to look too much at the tests. Let's look at lib. Is that what this is? No? Lib and modules and maybe Kubernetes. Okay, so lib. How big are we? Not too big. Libraries and mixins of Metasploit. Any code that will be reused across multiple modules will be placed into a library or mixin, which will then be placed under this folder. Okay, so let's look at telephony. Robots. Maybe is about robots.txt. Rex. I don't know what Rex would be. Here's some Postgres stuff. Here is maybe a main entry point. We have msf.rb expect. It sounds like something test related, but who knows? We have anemone and enumerable, and then a bunch of folders. And let's look at the MSF folder, the net folder, I guess Postgres, SNMP, tasks, and telephony. And I'll probably go through these pretty quickly because I'm not sure how interesting they're going to be. So this lib/telephony.rb just is, I guess, importing stuff from the telephony directory. Here's robots.rb. Let me get a drink. Okay, robots. And we have this link to a GitHub thingamajig. PhysX robots. A simple Ruby library to parse robots.txt. So is this just parsing robots.txt? It seems to be. It doesn't seem like it's like inciting a robot revolution or anything like that. So let's ignore it. Rex.rb. So I'm getting the feeling that this lib directory really is maybe just a little bit like utils as opposed to libraries that are useful in multiple exploits. It's maybe like on the boring side of attacking people. All right, so we have this thing, require rex/text, text manipulation library for things like generating a random string. Okay. So we have a library for creating PowerShell scripts for exploitation purposes, random identifiers, library for processing and creating zip-compatible archives. Okay, so some of this actually might be interesting. It seems like we're mainly importing a bunch of stuff from the Rex folder. Overload the kernel sleep function to be thread safe. Kernel class eval. I don't know. Is this like a Metasploit kernel or the Linux kernel? I'm not sure. But we're not doing much other than importing stuff. That stuff might be interesting. Let's look up kernel in this repo. Module kernel. Okay, so this is in the Win32 folder. We also have core/exploit/kernel mode, but that's a lowercase kernel, not a capital K kernel. We have a Linux kernel thing, and I'm going to guess the kernel is supposed to be the operating system kernel, probably the Win32 kernel. So that seems to be what uppercase K kernel with no other modifications is about. Okay, so here's lib Postgres. We could ignore that. It's too small to be interesting. Here's msf.rb. This is, I guess, going to just load some stuff, including mainly NTLM stuff, which happened to be like the first file we looked at. Here's expect. Expect library adds the IO instance method expect, which does similar act to TCL's expect extension. What? So we've got IO expect pattern timeout, blah, 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 returns an array. IO expect pattern timeout, a bunch of 9s. I guess passing in this, this looks like the cardinality of result. I don't know what these vertical bars represent in Ruby. It's going to return nil. Reads from the IO until the given pattern matches or the timeout is over. It returns an array with the read buffer, followed by the matches. So you give it some, okay, so that's useful. You give it some regular expression, and a timeout, and it's going to return you all the things that match that, which is like running grep, but with a timeout. Is there a grep timeout? Add timeout after some time. Yeah, you can just do, I didn't know about the timeout command, but there's some timeout command, and you can just combine Unixy stuff to get a similar behavior. But that's, that's a useful looking function. Anemone is just going to load anemone stuff, whatever is in the anemone folder. And similarly, I'm going to guess for enumeral. Although, no, we have the Cartesian product. What on earth is going on? So we've got a cross product of 2 or more enumerables. Okay, so we've got 2 things that, so enums, and we're going to do like the Cartesian product, I guess, create tuples of all the different combinations of the enums. I guess that's useful because in some, when you're searching for an exploit, you might be doing some sort of essentially combinatorics to try to, for example, passwords. So you might have an enum. Literally, you wouldn't do this, but in spirit, you could do this. So imagine you had an enum of all 2-digit numbers and an enum of common words, and you might use something like this to look for all passwords that were a common word followed by a 2-digit number or whatever. Okay, so here's the MSF folder, which seems like it's a bunch of the stuff that is interesting is going to be. Here's the net folder. I'm just kind of curious about SSH, but maybe not in the lib directory. Here's Postgres. I'm going to guess that this is maybe not so important. I am kind of curious about Rex. Let's see if we can eliminate modem.rb. So this seems to be like an old school modem. So we're going to initialize dev/ttys0. We've got this, I don't know if this is an enum, but something that looks a little bit enum-like, none, hard, soft, space, etc. And just sending stuff over the modem, I guess. Modem like utilities. And then we've got this local Linux kernel thing that I opened up. And then the last thing I'm going to do before I look at MSF is take a look at Rex. So Rex seems to be like largely string related. We have Google. I guess let's look at Google. We have like parsers and payloads and post and proto. Like I'm guessing protocol post. I don't know. Maybe for posting on. Maybe posting in the sense of HTTP or something. We have scripts, services, and UI. And tar. Transformer and user agent. So maybe this is kind of like browser stuff as well. Let's just try to figure out what it is. Geolocation.rb. So this is some Google Maps stuff. We're going to try to geolocate. Ask Google Maps API for the location of a given set of BSS IDs, MAC addresses of access points. What? You can do that? So you're going to send it some Wi-Fi access points and try to get a location to look up. What on earth? Is this a real thing? Okay, so I see. So you're supposed to send it a list of access points, Wi-Fi access points, and cell towers that the mobile client can detect. And it's going to return the latitude and longitude. I guess this is why Google had gotten in trouble for scanning everybody's Wi-Fi stuff. And I guess they were building this database. I really had no idea you could do this. Let's ask Gemini about it. So tell me about Google's geolocation API for Wi-Fi access points. It estimates a device's location when GPS isn't available or ideal. It takes data as an HTTPS request. It relies on the device itself to scan and report those nearby. And based on the info provided, it returns a latitude and longitude coordinates along with an accuracy radius. Okay, so how did Google build a database of where Wi-Fi access points are geolocated? Initially, Google used vehicles equipped with special receivers to collect Wi-Fi access point data. These vehicles were similar to the ones used for capturing street view imagery that would record the MAC address, unique identifier, of the access point along with the vehicle's GPS location. This method has since been discontinued. Currently, Google relies on data gathered from Android devices with location services enabled. When a user's device scans for Wi-Fi networks, it also transmits that information along with the device's GPS location, if enabled. Okay, so why was the streetcar one discontinued? I don't have specifics or privacy concerns. Yeah. Okay. All right. Well, that's a little bit creepy. Okay, so you can do that. That's a thing. All right. So what else is in Rex? So we have Postgres, I guess. So we have things like SQL, Postgres, MySQL. I don't know why MySQL is in Post. Maybe this is just general purpose database stuff, though. What is channel? Socket abstraction and stream abstraction. Okay. Proto is, we've got things like ADB, which I think is the Android debugger, DHCP. These are different protocols. Are these just libraries for the protocols? There's lots of stuff in Rex. So we have some client for, I don't know what we're doing. This is client.rb. Oh, HTTP/client. Okay, we're going to create a new client instance and initialize with port 80 with no SSL, etc. By default, I guess you can pass in other things. And this is just going to create an HTTP client. You can do things like send requests. Script, we have base script, interpreter script, and shell script. Let's look at shell. Nothing. There's nothing here. It inherits from base. What is base? We've got an output sync, which has things like, I guess you can print to there, like standard out. We can initialize a script. We give it a client, a framework, a path, and where it should send its output. And then we have this run function, which is going to take the args and flatten them. I guess you pass in the args as a list. And we'll flatten them to some string, presumably. We're going to read a file from the path. And whatever rescue interrupt, rescue script completed, etc., are, we're going to, I guess, try to run them. Maybe rescue is like, maybe this is like try catch in other languages, basically, error handling. Okay, and then we have services like local relay. This service acts as a local TCP relay whereby clients can connect to a local listener. Okay, all that's fine. But let's look up Metasploit Rex to see what like the documentation says about it. It's been archived. It is repackaging of the Rex library included in Metasploit framework used by non-Metasploit applications. Originally created by Jacob Hammock and made official by the Rapid 7 development team. Okay. But what is it? How about we look up Ruby Rex gem? A variety of classes useful for security testing and exploit development. Okay, so there's a ton of stuff in there. I can't go through it all. It does seem maybe like exploit specific, but I don't know if it has the exploits themselves. But that seems like a big part of Metasploit. There's a huge library which seems to be of independent interest, which is why they spun it off. But that's an interesting part of Metasploit. And let's take a quick look at Linux kernel in MSF core exploit local. And what do we have? We've got current task struct H with this meta asm or underscore exe, which has some, it looks like it's some assembly stuff for moving the stack pointer. And we've got like a header, which some sort of C file taken from sock sendpage.c. So we're just going to take this literal string and put it into a Ruby, or I guess maybe like pass it to cparser.parse. Where did cparser come from? I'm not sure. But I guess this is some sort of C interface with Ruby, and we're taking some code, it looks like, from the kernel and making it available to Metasploit somehow. What was that? That was Linux kernel RB. So that's what this is, right? Okay, so I'm not sure where cparser is defined. Maybe it's part of Ruby or something. It's something that's passed into init meta asm. Let's look at compile c.rb. So we've got, I'm not sure what the syntax is, but we've got some sort of CPU in C parser. We've got what appears to be a setup function, and it's just going to call init meta asm. I'm guessing asm is for assembly. And then we're setting the CPU in the parser. And I don't know where those actually come from, but they come from somewhere. Okay, so here's the lib/msf, which is probably really the heart of everything. We've got base core. I don't know what the difference between base and core is, but we've got UI and util. I'm going to guess that these things mainly just import stuff. Yeah, base is almost nothing. And core is almost nothing. They're just requiring some stuff. So in util, we have document generator. Oh, no, we don't care about util. Okay, UI has a console, a formatter, and a web thing. I guess there's some web console. Let's look up what that looks like. Okay, so I guess this is a web console. This is Metasploit Pro, so maybe this is only available if you pay, as opposed to the open source version. But you can do things like scan. I don't know how this is populated over here. Maybe this is only if you've started some sort of thing, but maybe the scan tool gives you the ability to pick an exploit when something is matched. Here's another view. This is also Metasploit Pro, etc. Okay. All right, so so we have core and base. Framework base. So the base library provides implementations for some of the default sessions, such as shell, Meterpreter, Dispatch Ninja, and VNC. Why VNC? Let's look up Meterpreter. Redirected. It redirects to Metasploit. The Metasploit interpreter enables users to control the screen of a device using VNC and to browse, upload, and download files. So that's why VNC. I think we saw somewhere that Meterpreter was, or Meterpreter scripts weren't used anymore, or something along those lines. Let's see if it's deprecated. Metasploit unleashed. I don't know, maybe it's still a thing. Beyond providing the default sessions, Framework Base also provides a wrapper interface to Framework Core that makes some of the tasks, such as exploitation, into easier to manage functions. And let's look at what the README for Framework Core says. The core library provides all the means by which to interact with the framework insofar as manipulating encoders, NOPs, I'm guessing no ops, payloads, exploits, auxiliaries, and sessions. Let's look up Metasploit NOP. NOPs. No operation. Yeah. By ensuring that any space not used by the code will still be validly executable. Has to do with writing instruction jumps. Jumps can be blah, blah, blah. If you know the pointer for the stack will point somewhere in a continuous range of memory addresses, you can fill that with no ops and then put your code after. Okay, so it's a way of ensuring that memory looks a certain way to make exploiting easier by inserting no ops somehow, some way. That's how I'm going to think about it. Okay, so I don't know. I feel like core is maybe more interesting. How are we on time? We're about an hour in. And we still haven't looked at the database really of exploits. So I'm going to probably go pretty quickly through the remaining stuff. And, if you want to know more, you can dig in a little bit yourself. Okay, so in base, we have things like persistent storage, serializer, which is probably not so interesting, session and simple, and some logging stuff. Okay, so that's core. We'll get to core in a second. Serializer has things like serializing JSON, I guess, and some readable text stuff. And then in sessions, we have AWS stuff. AWS, Instance Connect, Command Shell Bind. We have command shell.rb, encrypted shell, hardware bridge, mainframe shell, and meterpreter.rb. Let's just pick on maybe meterpreter ph.rb, meterpreter Python. Let's just pick a few of these and see what we see. Scriptable, Postgres, VNC, inject. Okay, just look at a few of these. Simple is what? I don't know, but I'm going to ignore it. Okay, so here's command shell.rb. This class provides basic interaction with a command shell on the remote endpoint. It's initialized with a stream that will be used as the pipe for reading and writing the command shell. Okay, so we're including some stuff, including some rec stuff. We have this command to execute a file, which will, I guess, run some file on the remote shell. I don't know if you pass it a file on your disk and it like sends it to the other shell, or if it is supposed to be a path on the remote machine. We've got some initialization stuff. Calls the class method. So shell init is just going to return true. The shell will have been initialized by default. Okay, some bootstrapping stuff where we look in some data store and see if auto verify session is on. If it is, we set session info to the empty string. And we read the output and mash it into a single line. Okay, so we're going to read some output and somehow mash it to a single line and do something. I don't really know what that's about, but maybe getting like the shell header or prompt or whatever. We've got the shell banner. That's, I don't know what that's doing. We're going to echo some tokens, et cetera, et cetera. Okay, so some shell stuff. Encrypted shell, I'm going to guess, is maybe something like SSH. I don't know, but we're looking up some stuff in the data store, some key value stuff, including a cha-cha key. And if we have a cha-cha key in, I guess we might have a nonce, and the IV is some nonce, then what? We're going to somehow do that. So we're going to do some sort of cha-cha, send some cha-cha credentials, I guess, passing in some UUID, whatever our stream is. But why? Is this for Windows? Windows payload dbconf. So I guess maybe Windows uses cha-cha for shell encryption. Maybe it's just OpenSSH. It's some sort of, it seems to be some sort of Windows shell that has encryption. HW bridge is an interactive session with a hardware bridge. The hardware bridge must support the current API supported by Metasploit. Okay, what is that? What is the current API? I don't even know how you would talk to a hardware bridge. So we seem to get some sort of console, like maybe like a serial console. And what can we do? Session info based on the type of hardware bridge you are connected to. Okay, so it comes after connecting and pulling status info. Okay, I don't know. Is this a hardware bridge console protocol? Yeah, I'm not sure. I'm not really sure. I thought like different like bridge manufacturers had different different sets of commands and stuff. So I'm not sure if this is if that file was like a general purpose file that gets instantiated for different manufacturers or what. But I wasn't really sure what they were up to in general. Here's mainframe.shell, underscore shell.rb. This class provides basic interaction with a Unix system service command shell on a mainframe, IBM System Z, running ZOS. Okay, so this is more just shell stuff for different machines. And I expect it more or less all looks similar with different implementation details. Interface to an interpreter server, instance running on a remote machine. So I don't know if this is for like you have maybe an evil machine inside somebody's network, and I guess maybe this is to give you persistent remote access or something. Let's ask Gemini. Let's ask ChatGPT. Tell me about and how it's used. And then we'll come back to it. Okay, so here's Meterpreter PHP. And we're just going to do some stuff like check if it supports SSL and zlib. And then be able to initialize it just by setting the platform to PHP. And here's Python. We've got some, seems to be opcodes. We've got some error CRCs. Okay, so these are like, I guess the like hex code and then the corresponding Python error or something. And then initializing, we're going to set the base platform to Python. We can look up the error code, I guess, by doing some computation and checking which of these it corresponds to. And we record whether it supports TLS or zlib, etc. So Meterpreter is a powerful payload included in the Metasploit framework, which is an open source penetration blah, blah, blah. Provide a stealthy and versatile way to control compromised systems during penetration testing, post-exploitation, and red teaming exercises. Here's a breakdown. So it's a payload. The payload is Metasploit is a payload used by attackers after they have successfully exploited a system using vulnerabilities or social engineering techniques. It's typically injected into the target system's memory, making it difficult for traditional antivirus software to detect. So it's versatile. Stealth. It's designed to operate stealthily on compromised systems. We've got command and control. Once Meterpreter is deployed on a target system, it establishes a communication channel with the attacker system, allowing the attacker to remotely control the compromised system. Okay. So it is like it is a thing that you install on a device that you've owned, and you can, I guess, control it remotely. All right, so we're going to ignore the rest of these session stuff, and that leaves us with core, I think. We've got a data store, which we saw, I guess, called. We've got DB connectors and let's look at exploit driver, exploit event, framework, maybe the module thing, maybe no op, some opt stuff. Maybe I'm guessing this is options, perhaps. Payload set. We'll ignore, I guess, platform plugin. Some more session stuff. Target. Okay, so let's kind of blast through these. So data store is just a bit bucket that holds key values. Okay, so it's some key value store implemented as a bit bucket. Evasion is, I'm going to guess, for evasion. We've got this, I don't know what this is. Maybe, I guess complete is a type of runtime error. Failed is a type of runtime error. And we've got this initialized thing. And we are looking up payload in info. I don't know if info is another key value thing, basically hash table. So if all of these conditions are true or whatever, then we end. I'm not sure what those conditions are, but we'll ignore them for now. Set the payload info to whatever is inside of info. I'm guessing that comes from like the individual exploit. And then we're going to transform whatever info targets is into something. Somehow we're maybe changing the data type or whatever. And if it's the default target, I guess we'll set the info to the default target. Otherwise, we set default target to 0. And add an auto target to the evasion if it doesn't have one. So we check if the number of targets is more than 1. And if it doesn't have auto target, then I guess we're done here. Finally, only add the target if there is a remote host option. So we look at self-respond to remote host and self-respond to auto-targeted index. And I'm not really sure what any of this is doing, but somehow it's adding some targets or whatever they are. This is some sort of timeout stuff. And then we're going to register options. File name for the evasive file. Okay, so I don't know if the evasive file has like is like the file you want to hide. I guess it is. We're going to call out some stuff that seems to be like random text with possibly 3 to 10 something or others in it. Okay. We've got this file create thing, and we're going to pass it in an evasion file format. I guess this is designed so that you can, if you know what like antivirus software or other scanners are looking for, you can try to give it a file name that's deterministic, but that the scanners are not looking for. Target platform just gives you the target's platform. Normalize platform arch. So this seems to be kind of like normalizing some sort of string. Is payload compatible? Returns whether the requested payload is compatible with the module. And how do we determine that? We look at the framework payloads. And if we get nothing, then we return false. And we can just ask if it's compatible, and so on and so forth. And we can ask about privilege. If the payload is privileged, but the evasion does not give privileged access, then fail it. Okay, so I don't think we've seen what an evasion is, but this is some sort of code for evading, and it's like reading some information from, I think, the individual exploit and stuff like that. Okay, here's exploit.rb. The exploit class acts as the base class for all exploit modules. It provides a common interface for interacting with exploits at the most basic level. Okay, so this is like the abstract base class in a sense. So we have the exploit class, which extends a module. We've got this complete and failed errors. Default compatibility settings for expert modules. Okay, and then we've got some sort of payload. Support reverse bind in non-con connection types. So somehow, I don't know what the syntax is, but we've got essentially, seems like a help string. Connection type, reverse bind, not, oh. No, I guess maybe it's like setting the variable connection type to some list. We've got check code, which is a type of struct that I guess maybe has code, message, reason, and details. Various check codes that can be returned from the check routine. So I guess there's some check routine, and it will check. It'll like defer to one of these methods or variables in this struct or whatever. What else do we see? The target is safe and is therefore not exploitable. This is recommended after the check fails to trigger vulnerability or even detect the service. So I don't know what this syntax is doing, but we've got these seem like a bunch of methods. Like maybe you can implement safe or whether it's detected or whether it appears. The target appears to be vulnerable. This is recommended if the vulnerability is determined based on passive reconnaissance. For example, version, banner grabbing, or having the resource that's known to be vulnerable. Okay, and we've got some mixins. Load all of the exploit mixins. Returns an array of all the exploit mixins. Lame algorithm right now. Okay, so I guess we can improve it. And I don't know. Et cetera, et cetera. Okay, so let's maybe just look up one of these. Like let's look up safe and see if we can find an implementation. I don't really see one, but I also don't know enough about it. Okay, here's exploit driver. The class drives the exploitation process from start to finish for a given exploit module instance. It's responsible for payload generation, encoding and padding, as well as initialization handlers, and finally launching the exploit. Okay, so this seems like an important file. Okay, so we've got a payload, an exploit, whatever a use job is. We've got a job ID, force wait for session, etc. And whatever a target index is, maybe we've got a list of targets and we're looking it up in some data structure. We can check to see if there's a compatible payload. We've got this validate method. And I don't know. This seems to be pretty like running. This seems to be mostly just like running a job, seeing if it's working, seeing if it failed. This doesn't seem to be like particularly that you would need, for example, knowledge of exploitation to understand this file. So I think since it doesn't seem to be as focused on Metasploit's key skill set, I'm going to move past it. Here's framework.rb. I think that we're just going to, I guess, plow through all of these and head over to the modules and maybe take a look at some of the exploits. Where are we? We're about an hour and 10 minutes in. Okay, so let's look at some exploits. Apple, iOS, BSD finger, Firefox logo. Let's look at Firefox. Linux, I guess, why not? OpenBSD, OS X, Solaris, Unix, example.py. I guess let's look at the examples. Here's example.py. We're going to import logging. Say that dependencies are not missing. We're going to try to import requests. Okay, and if we fail, we'll say dependencies are missing, and I guess have some sort of error. And we've got some metadata, which is just some string that appears to be JSON. And maybe this is similar. This is maybe the file that we saw before in the database directory. That was this huge list of exploits. And then we've got run, which is going to take some args. And are we extending a class here? I don't see yet. Okay. At any rate, we've got run. We're going to set up logging, check if dependencies are missing, and if so, send an error. Then we're going to try to, using the requests, Python requests module, we're going to try to get some URL from passing in our host. And our host is something that we've seen before. That's like the remote host. So I guess this is being called by Metasploit. And Metasploit is passing in things like the remote host, the target URI, the commands, and maybe the command. I guess the commands are going in the query parameter, and verify false. I don't know what we might be verifying that we're not. And if there's an exception, then we log it and return. Otherwise, we just log the result text, I suppose. whatever request returns. And then in the main function, we just call module.run. And module must be from what? Some Metasploit thing. Yeah. Okay, so that gives us a sense at least of how you would implement an exploit. You basically just have to implement run. And we don't, we're just passing in like a dict of args. And I guess it's just your job to know that Metasploit args look a certain way. Here's another example. This is a Ruby example. And we've got some initialize function, and I expect it to be mainly the same. We've got this, we're going to call update info. This seems to be recording the metadata, which we saw in Python seemed to just be setting a string. We've got check. The sample exploit just indicates that the remote host is always vulnerable. So when you ask for check, when Metasploit like checks this exploit, we're going to always say it's vulnerable. It's just the constant function that returns check code vulnerable. The exploit method connects to the remote service and sends 1024 random bytes followed by the fake return address and then the payload. So we're going to connect, and then we're going to echo, I guess, to the console, some sort of console. Create a buffer with a bunch of random bytes, pack them, and do something with target.ret. And then whatever this payload encoded stuff is, I guess maybe encode stuff. Then we're going to put the buffer on the socket, and then we're going to get the response, I guess, by calling get once. And then whatever handler is doing, I don't know. Seems to be handing off execution to something else. Okay. So that's useful. What is Linux antivirus? Let's just take a look at a couple of these. How about SSH. Quantum VM Pro backdoor. Yeah, let's look at that. Okay, so this module abuses a backdoor command in Quantum VM Pro. Any user, even one without admin privileges, can get access to the restricted SSH shell by using the hidden backdoor shell escape command. It's possible to drop to a real root bash shell. This module has been tested successfully on Quantum VM Pro 3.1.2. Okay. So we're going to register some options. We're going to, I guess, support our host, our port, and a user and password. I guess, and it has these formats. And I guess it's Metasploit's job to be able to interpret any option like this. And then we have some advanced options like debug and timeout. And we're registering those as well. And then when we, I guess when our host, I don't know if this is defining what happens when our host is like called or looked up, but I guess we're defining an our host function that just looks up all caps our host into the data store. And similarly for our port. And that function seems to be used here. So on do login, we're going to call SSH client defaults merge. SSH client default. I guess that's like the default SSH client. And then we're going to merge some stuff. I guess this is maybe packing these options into some sort of other structure. And we'll say that the auth methods are password and keyboard interactive. And we're passing the port and password. And then we're merging options here. If we are supposed to be, okay, so we're adding debug and verbose to the options if we've enabled SSH debug. What am I doing? I'm looking at the Metasploit code. The Metasploit source code is what I'm doing. And then we're going to begin. And we're going to set SSH to nil. We've got some timeout. I guess we're going to try to connect. And then if we get connection error, we'll do some stuff. And if we have an SSH object, I guess connection succeeded, then we're going to send a new SSH command calling net SSH command stream.new. And then we're going to return the connection that we get by calling that command. And then we're going to return nil. And then the exploit function is going to set user and password from the data store. And then we're going to just print some stuff saying that we're trying to log in, and then we're going to call do login. And if we get a connection, then we're going to call handler of connection LSOC. And so here's do login. That's the thing that tries to run shell escape. So after we run shell escape is when we're handling it off to handler. And I'm not really sure what handler is. I guess we should figure that out. What kind of framework is this? It's a framework for exploitation. Let me send you the link here. Okay. So here's handler. This class acts as the base class for all handlers. And what does it do? We've got, I don't know, relative resource, blah, 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 at accessor. It's like an HTTP handler, maybe? Is that what it's saying? Handler generic. Maybe this is what I want. Returns the handler type of done. Maybe this is better for documentation. Generic payload handler. This module does basically nothing. Because of this, it's missing a disclosure date and makes MSF Tidy angry. The module is a stub that provides all the features of the Metasploit payload system to exploits that have been launched outside the framework. Okay, so maybe payload handler is really what we're doing. Let's find payload again. So here's payload. Do we have a handler? Yeah, I'm not sure. Let's try ChatGPT again. What was I asking it? Okay, so tell me about so I see that exploits often end by calling handler. What does that do? So a handler, often referred to as a payload handler or exploit handler, is a component responsible for managing incoming connections from exploited or compromised systems. So it manages incoming connections from the system that you've owned. When an exploit successfully gains access to a target system and executes a payload, it establishes a communication channel back to the attacker system. The handler on the attacker side listens for these incoming connections and manages the communication with the compromised system. Okay. So it is kind of like an HTTP handler, except that they're maybe more general. We're going to handle any sort of incoming connection-y stuff. Here's an antivirus exploit. I don't know what this is about. This module exploits a command injection vulnerability found in eScan web management console. The vulnerability exists while processing check pass login requests, etc., etc. Okay. Here's a Firefox one. This module allows execution of native payloads from a privileged Firefox JavaScript shell. It places the specified payload into memory, adds the necessary protection flags, and calls it, which can be useful for upgrading a Firefox JavaScript shell to an interpreter session without touching the disk. Yeah, that's right, cybersecurity stuff. In general, though, we're just reading different open source code repos. So this one happens to be cybersecurity, but we're going to very shortly be looking at something else. Not sure quite what, but something. Okay, so we've seen a couple of exploits. That was useful. Let's take a quick look at Kubernetes, and then I think I'm going to take a break, and we will pick another repo. All right, so we have interpreter. I guess there's some interpreter shell or script for Kubernetes. We've got some chart with some values. I guess we're using Helm. And the config map. I guess this is maybe just running Meterpreter on Kubernetes. Is that right? Keywords, Metasploit, Meterpreter, security, etc. Okay. So that's just the Helm chart. And then we have some values. I guess we have some Metasploit container. And the image is Metasploit framework, etc. We might have some security escalation stuff. And we have some config map, which is going to call MSF Venom with this reverse TCP thing. So this is, I guess, just somehow maybe just setting up the ability to egress or ingress, perhaps, whatever MSF Venom is. MSF Venom is a combination of payload generation and encoding. It replaced MSF payload and MSF encode in 2015. Okay, so some payload encoding thing. Okay, so it seems like the Kubernetes stuff is just like, let's run, we've owned Kubernetes, so now we're going to run a Meterpreter shell inside Kubernetes. Okay, so I'm going to stop Metasploit there. That was very instructive. We went from, at least me, not really knowing anything about what it was or how it was architected to having a sense of, a better sense of what they're doing. Written in Ruby. Again, I don't read Ruby. I don't think I've ever read really Ruby before. But a lot of it was pretty sensible. And the basic gist is we have a bunch of tools and utilities that let us do things like create SSH connections, create HTTP, TCP connections, all the different types of connections. I think we saw a lot of that in the sessions directory. We have a bunch of text manipulation utilities that can be used to combine them together to do various things like maybe like combinatorics or like string manipulation so that you can calculate things for your payload. We saw a little bit of the evasion stuff, but I think not really much of it. And then the exploits are just essentially scripts that a lot of them look pretty simple, where once you figure out what the vulnerability is, you just have to do an implementation in the kind of language of Metasploit. And it's Metasploit's job to make sure that they have like hooks and handles and Lego bricks for all the things you would need to do exploitation. And then once you've exploited something, then they're gonna then I think the typical case is you put a Meterpreter shell, which we didn't really see how the Meterpreter shell worked. That would be interesting to see. I'm not sure. Given that we don't have much time, I don't know if there's much we can do to do that. But maybe I can ask Gemini a little bit about it. So what did I ask before? Okay, so let's ask about, tell me about Meterpreter shells. How do they connect? So what kind of connections do they support? Hello, Mr. Durf. Good evening. It's morning for me, but good evening to you. Actually, it's afternoon for me. Okay, so Meterpreter shells are a powerful tool, blah, blah, blah. A payload goes beyond basic shell connection types. A reverse TCP connection. So the target machine initiates the connection, which makes sense because typically you can egress out of a network better than you can ingress. The attacker sets up a listener on their machine. Once the exploit is successful, the target connects back to the attacker listener port, establishing two-way communication channel. Okay, so does the shell try to reconnect if the attacker machine disconnects? Okay, so by default, it won't try to reconnect. It relies on the compromised machine. Well, that doesn't mean it can't. Okay, so you can auto migrate. Can be configured to automatically migrate to another process on the compromised machine. Did I ever ask her if the attacker, I think it misinterpreted my question. Or maybe I asked the wrong question. So what is it calling? The compromised machine initiates the connection. Blah, blah, blah. So, okay. So, custom post-exploitation modules. Maybe this is right. Advanced users can create custom post-exploitation modules for Metasploit that implement functionalities like reconnection logic. These modules can be designed to attempt reconnection to a predefined server at the attacker's machine if the initial connection drops. Okay, so you can do that on your own, but it doesn't do that by default. That's good. Okay, so that's Metasploit.